Normal distributions are for when your data, it mirrors a binomial. So if you did do any of those histograms, congratulations. But you get normal distribution after, if you have a larger sample size and your data follows what looks like a bell curve. So you guys have probably all seen normal distribution, the good old bell curve. But have you seen paranormal distribution? Because we moved the test Monday.
Oh, nice.
So, hey, this is. You know what I say? You can bring me a coffee. That's a good one. You're dumb. Anyway, so normal distributions, don't write any of this out. What happens here is that as curves, and whenever you have probability, when you have a binomial distribution, after you get a value of your n value is larger than 5, it usually starts to norm itself out. What that means is, over the course of data, you're going to have expected values that reach towards the middle. When you reach towards the middle, you're reaching towards the average, the mean. Okay, that's where mean, median, mode, all that kind of stuff comes back into play a little bit. Not that you have to do mean, median, and mode, so don't freak out about that. But what you look at is expected value. So what happens with a lot of normal curve stuff? Bless you. Actually, draw this out first. What happens with normal curve? It's not too bad. When you have a normal curve, 100% of all of your data is under the curve. Okay? Then it won't be a normal. Okay. The idea of using a normal curve is that you know that 100% of data is under the curve. Not to be confused with under the C. What commercials?
You showed last.
I did not.
Yeah, it was.
What commercials are you talking about? What commercials? Now, in a normal curve, normal distribution, you've got, when I say that you have 100% of data is underneath the curve, that means the total area under the curve is 1. Remember, because it's 100%, so move that as a decimal, it's just 1. Half of all the data is to the left and to the right of the mean. What does the mean stand for again? The average. Now, what happens then is that you get these things that are called standard deviations. Have you ever heard of that term before?
Yeah.
I'm not going to have you guys calculate standard deviations and work through any of that. There's no reason to do that in this class. You can do that in a stats class. It's a relatively simple thing, but the stuff that I'm going to look at with you guys is that I'm going to ask that I will give you what the standard deviation is within a subset of data. What you'll have to remember is what's the area under the curve that's within the standard deviation. So what happens here is that you get standard deviation rate. Now, within one standard deviation, so this is minus 1 SD plus 1. So when you go within one standard deviation, it's tricky, man. See what I did there? It's like 3 for me today. I'm doing 3. Bye, everybody. Adios. So you get 68%. 68% of all data is within one standard deviation of the mean. 68% of the data. Anything that's norm. That's the idea. Once you know that you have normed data, and that's the idea. There are. Remember when we were looking through the calculator? We went to the bars thing, and you had all those different like Poisson distribution, binomial distribution, all those. The Z testing, things like that. What all of those statistical inferences and data tests are doing is that they can take all those different programs and stuff, and then therefore norm the data. Because if you're able to norm the data, then you're going to be able to take, oh, I know that 68% of things will happen within one standard deviation. I will know that those breakpoints will occur. And that's the idea of how this comes about. Yes, sir?
Why is it 68?
Because of the way bell curves work.
Just the way it is.
Yes. This is the intro to stats of intro to stats. So if it's 68%, this is symmetrical, which means this side is 34, and this side is 34. Okay? All right. So far, so decent. The next one happens then when you go plus or minus 2 standard deviations. Good morning.
Good morning. I need Madeline.
Ooh. Ooh. Robots are fantastic. Within, I always forget these numbers off the top of my head. Within 2 standard deviations, is 95% of all data. Okay. 95% of all data will happen within 2 standard deviations of the average. Okay. Now, that means as you start breaking down your chunks, because everything is symmetrical, if 95% is cut in half, well, what's half of 95? Okay, so 47.5 would be on one side, 47.5 would be on the other. Well, if you subtract 34 from 47.5, what do you get? Okay, it starts to break it down. And then after 2 standard deviations, you get a standard deviation is a measurement about the mean. What that stands for is it's like a break point from the average. Lack of better terms. Now, a 3rd standard deviation is usually as far as you will ever go with any normal data, because everything else out there becomes what's called an outlier. Okay? So within 3 standard deviations, you're going to get 99.7% of all data. Within 3 standard deviations is 99.7. 99.7. So once again, if you take the 99.7 subtract the 95, you're left with what? 4.7? Well, that means this portion here and this portion here would account for 4.7 of the total data, which means half is on either side. What is it? Correct. So you have 2.35% here and 2.35% here. Now, if 99.7% of data is all within 3 standard deviations of the mean, that means that 0.3% are on the outliers, which means on either side then, was it 0.15%? So 0.15% is out here, and 0.15% is out here. Now, I've seen T-shirts before. Yes. I actually own like 3 or 4. I don't know. We do. It's nothing is better than what it is now. So if you've got the normal curve, and then I've seen a T-shirt where people have done this. I can't spell. Because you.
Oh, are you wearing that shirt?
Yeah, we took that negative outlier.
Oh, I get it now.
I don't remember. My IQ is not strong enough to remember those minuscule data points.
That's not an
SMRT. So the idea with these things here is that when you get into statistical inference, statistical data, if you happen to have, when they say that distribution has been normed, you'll be able to figure out percentages of where things are going to occur.
That's an improperly labeled curve.
I'll get over it. Please, by all means, not yourself. So let's see here.
That's what all of this.
So what I would do is this, is that we know it's going to be bell curve. Hey, somebody flip a coin. Call it. Heads. All right, fine. So what I would do is this.
It's heads. Didn't even notice. I wasn't over there and it's heads.
Anyway, so I would do this. And I'd have this on a handy sheet, maybe nearby. So it'd be 0.0235. You can leave it as percents. I'm switching it to decimals, and then the outliers 0.0015 and 0.0015. And that will accommodate all data underneath the curve. Average. Yeah. What happens then is that you can do this. Did I just? Oh, there it is. A survey shows that the time spent by shoppers in supermarkets is normally distributed with a mean of 45 and a standard deviation of 12. So that tells you that the average amount of time someone spends in a grocery store is 45 minutes. So that tells me that I can put my average in the middle at 45. It says that it has a standard deviation of 12, which means If I move over 1 standard deviation, how many minutes did they spend? 57. If I move 1 less standard deviation, how many minutes did they spend? 33. So that means between 33 minutes and 57 minutes, 68% of all people, that's what they spend at the grocery store. As you start thinking about where this standard deviation stuff comes, and you can kind of start seeing, oh yeah, that kind of makes sense. Okay. If you go 2 standard deviations out, that means that if I add 12 more minutes to 57, I'm at 69 minutes. If I subtract 12 minutes from there, I'm at, what, 21, sorry. 2! Sorry. Now, within 2 standard deviations, that means that 95% of the time a person grocery shopping spends between 21 and 69 minutes. If you're at the grocery store for more than an hour, one of 2 things is happening. You're at Costco and you are just surveying the food. Yeah. You're just wandering around taking it, you're just like eating lunch there.
Or you're lost.
Add 12 minutes to that, we get what? 81? I could get in and out of Aldi. I can get out of Aldi in easily less than 20 minutes.
Easy. That's more than 9 minutes.
Yep. Nope. No, we have my wife. We were last time we went to IKEA. They've got those big giant blue tarp bags. You guys ever seen those? So we've got a couple of those. IKEA is pretty cool for. We have it's just basically it's a blue tarp with a strap that says IKEA. So we have 2 of those bags. We take them with us when we go to the grocery store, and then I just start loading things as we're going through. And cashiers, they're like, I just throw in the bag and put it in there. I'm out. So I know where everything is. I make a list of what I need to get. I get.
Yeah, but you don't wait till you run out of everything in that house.
I will no. Children eat a lot of food, so we hardcore shop every Saturday or Sunday morning. And what's that? We're always grocery shopping. We meal. Anyway, so what happens here? What happens here is that we know that the data has been normed because it said so. Oh, have you ever seen that symbol? X with a bar over it, that stands for average. Sometimes you will see a theta, that's a lowercase theta, that stands for standard deviation. Whatever you want to think it is, it's a lowercase theta. Guys, listen. This is on your test, so whatever. Between 33 and 57 is 1 standard deviation. How much percentage of the time does that occur? That's it. That's your answer. Correct. And that's it. I'm writing it out so you can see why the data works, because all these percentages never change. Really, all you need to know is 68, 95, 99, 7, because then everything's symmetrical. You cut it. What's the probability a randomly selected shopper will spend between 45 and 69 minutes? Well, 45 and 69. Well, here we go. If this is 34, and then this was what? 13.5. So what would you do for that? Just add them up. So what was that? 47.5. That's the standard deviation. That tells you where these breaks are going to occur. If your average is at 45 and a standard deviation is 12, that means I add 12 for each break point. Yeah. Yeah, that's I don't know. It said there was standard deviation as well. So it's going to be given to you. Hey, we're doing standard deviation. Look,
They're doing stats too.
look at this. Look at my symbol I made. No, look over there, the sign.
I am here.
Hey, this is the probability of randomly selecting 40 multiple choice questions out of 50 with a 25% chance of each one being right.
Yeah, plus or minus 15 for IQ? Plus or minus 10.
I don't know. I'm not that smart.
I think it's normalized in 100, it's plus or minus either 15 or 10. I know, I've done these problems before, but it's been a really long time.
What's your IQ?
Yes. I got a 1500 on my SAT. That's pretty good. Back when I took it as I was 24.
Why do you keep stepping on my cords?
Oh my goodness, this is amazing.
Hey, back to the LSD.
What?
Yeah, sit down over here.
Did you look it up? What?
Hey, look at this. No. Shut up, you're making me crazy here.
Look it up.
Actually, they're called
I'm not gonna. I can't.
Okay, so I was right the first time. Never second guess your instincts. I was right the first time. Sigma's 15.
All right. Hey, all right. Probability of guessing 40 multiple choice questions correct out of 50 with A, B, C, D as answers.
Conveniently, also the odds of having two identical scantrons. So when you get 7 of them on the same final.
Someone didn't know.
Some people aren't very smart when it comes to trying to cheat.
No, they're really not.
And then your suggestion is usually we'll just change 2 or 3 of them. That really affected that much? Stop cheating!
We had there was a few years ago. All right. Color blindness. Use the fact that approximately 2% of people are colorblind. Oh, wait, this is a different problem. Sorry, this is different. Oh. According to the survey by the National Center of Health Statistics, the heights of adult men in the United States are normally distributed with a mean of 69 inches and a standard deviation of 2.75 inches. If you randomly choose 3 adult men, what is the probability that all 3 of them are 71.75 inches or taller? Okay. So, 69 inches is 5'9". That's what they say is the average height of a man. Now remember, the textbook here was written 6-7 years ago. We looked this up, I think, last year. I think it's gone up just ever so slightly. So, when you look at it, so 69 inches is 5'9". If you add 2.75 inches to that to go in one direction, that is what, 71.75? Add 275 to that, and you get what? But I know where you're going with that. So, but I know what you're talking about. You want 6.71.75. So think of it this way. We know that this is 0.34 here, correct? What's all the way to this side then? 50%. Good. Which means from here over is how much if this is 34 and 50? 16. Good. So 16. So what you're saying is 0.16 or 16% of all males will be at least, what is that, 71 inches? So that's 5'11 and 3/4. So what that says is that only 16% of adult males are almost 5'11" and 3/4. That doesn't seem very much because myself, I'm 6'3", you're 6'3", you're what, 6'2", right? Yeah. No, you don't think you're taller than that. Really? I thought you were taller than that. You look taller than that. You're 6 foot, aren't you?
You're like the cutesy people.
You're 6 foot, and you're 6 foot, you're all 6 foot. So, is that stuff So, the idea, if I'm randomly selecting 3 people to be taller than 5'11" and 3/4, the probability of getting one person that tall would be 16%. 2 people would be 16 times 16. 3 people would be 16 times 16 times 16. So the probability of randomly selecting 3 people would be 0.16 times 0.16 times 0.16. So you can still utilize probability like we have been with this. These normal curve stuff with the standard deviation values are allowing you to figure out what those percentages are going to be. These percentages will never change. 68, 95, 99.7 outliers. Okay? If you remember that, and then how this symmetry works, it's really, really easy to do. Okay? It's got its left and rights. Can't you just make stuff up?
I tried doing that fast, it doesn't work.
Alright. Oh yeah, 80% of the stuff I say is true, 20% is made up. You have to figure out what's right. But I did a lot of 80% work here because I had to tell you the right way of doing stuff. So a lot of times when I'm actually teaching, it's 100% true. The other stuff is just a little investment. Not embezzlement, embellishment. I'm not embezzling.
You have something good. Shut up, Emma. Not so serious.
What's that? What crack? $68, $95, $99.7. That's all you gotta remember. 68, 95, 99.7, and everything else is symmetrical. 68, 99, 95, 99.7. Hey, will you guys do me a favor real quick before you get